Okay, so we have this nice spring. Oh look, simple harmonic motion. And we have this 5 Newton mass. Now what I'm doing is I'm hanging this 5 Newton mass from the spring. So there's the spring's equilibrium position, and in order to keep it from going crazy, I'm letting the mass hang down, and I'm carefully measuring it, and it has extended, oh look everybody, it's extended exactly 10 centimeters. Isn't that handy? Well, really it didn't, but let's pretend that it did. And what we want to know is, what is the spring constant of this spring? Okay, so let's start with a free body diagram. So here's the mass. Here is the force of gravity downwards. And here is the, oh, and that's 5 newtons. Did I say mass? Because what I actually meant was weight. They are different, because this has to work on Mars too, or the moon, or potentially Jupiter. So anyways, this is the force of gravity. And this one is the force of the extension of the spring. So springs are, they have this kind of an oppositional defiant disordered thing going on. Like no matter what you do, they want to do the opposite. And so force of extension of the spring, if everything is at equilibrium, it's going to be 5 newtons as well. And this is bobbing around just to try and embarrass me. Okay. But really the acceleration of the system is 0, and so the forces are all balanced in this case. And so force of gravity plus the force of extension of the spring is equal to 0. And it can be tricky, I don't know. Let's say that down is negative, and so gravity is down. Now, one of the formulas that we know is that the force of extension of a spring is equal to negative kx. And k, we just have to watch our sign here. This means like in the opposite direction that the spring is pulled. And in this case, it's going to be up. Okay, so force of gravity is 5 newtons, and plus kx, that whole business is equal to 0. We actually know what the extension is. We're told that it's 0.1 meters. And that is all equal to 0. Haha, did that backwards. And now I'm all ready to go move everything around. And of course that's negative 5 newtons. And so when I move everything over to the other side, k is equal to 5 newtons divided by 0.1 meters. And so k is going to be 50 newtons per meter. That's that. Reasonable?